All right, welcome back. We're going to start lesson 2 in unit 2, which starts on page 8 of our workbook. And we'll be working through the green section here. And in lesson 2, we're going to talk about operations with integers. But we're really going to try to focus on using the number line to help us do some of these operations. Okay. So if we turn to page 8 in our notebook, we will go ahead and get started. All right, so we can kind of use the number line here to help us add some things. So here it says, in each box, put the sum of the numbers that it points to. Okay, so here they've started with 9 and they've kind of, it's hard to understand, but they took 9 plus 9 to get 18. Okay, and then 10 plus 8 will equal this box, which is 18. So this kind of helps us realize that 9 plus 9 is the same as 8 plus 10. Okay, and if we go out one more, 11 plus 7, that's again 18. And then 12 plus 6, that is also 18. 13 plus 5, that is also 18. And then 4 plus 14, which is also 18. This helps us show some of the great symmetry that a number line can have. Okay, and help us do some addition. But as you'll notice here in just a little bit, it doesn't only help us with addition, it can help us with some subtraction as well. You can determine whether these mobiles are balanced without having to add up the numbers on each side. If they are balanced, write equal in the blank below. If they are not balanced, circle the heavier side and write less than or greater than. Okay, so math can be broken into like two ways you can do it. One, you can actually do the math and add things together. Or you can look at it visually and do some what people like to call mental math and just look at it. Okay, so if we look at number 2, we got 63 and 37 on this side and 65 and 37 on this side. It says if you think first, you can do it without calculating the sums. Okay, well, we know that 37 and 37 will equal and they will always balance out. And you should know automatically that 65 is more than 63. So this side here will be heavier. Okay, 65 plus 37 will be more than 63 plus 37. Now, I don't know how much more. I mean, we could figure it out. You know, 65 is 2 more than 63, so it'll be 2 more. But just a quick glance at kind of the weights, we know that this side will be more. Okay, so 51, 74, 50, 75. Okay, without adding it all up, we want to know, you know, are they equal or what side is heavier? Well, I know that 74 is 1 less than 75. Okay, but then I know that 51 is 1 more than 50. Okay, so if you think of this as like a minus and this is a plus and both of these are equal, you know, you got 75, so there's a minus 1, but 50, there's a plus 1. Those cancel out and and it's all balanced. Okay, they're the same amount apart. Okay, so those are equal. Here we have 94, 123, 120, 95. Okay, well, this one is 3 more. So then that'd kind of be lopsided this way, heavier, 3 more. This one over here is 1 more. So it kind of comes back just a little bit. But there's still a difference of 2 here on this side. So this side here is heavier, heavier by 2. Okay, so we're just using the distance those numbers are away from each other. All right, find the weight of N that makes the mobile balance. Okay, so we've got 43, 28, 30, and N. Okay, so if we kind of just do it without having to add or subtract anything, I know here that 28 is 2 less than 30. So right now my mobile is kind of sitting like this. 30 is 2 more. In order to balance that out, I'm going to have to make this side heavier, okay, or this side less. I only have N to be able to do that. So in order to do that, this number over here has to be 2 more than this side, or this side has to be 2 less than 43. And 2 less than 43 is 41, okay? Because this has a plus 2. So if we put a 0 here, this one has a plus 2, okay? And then if I have a 0 here, this one has to be a minus 2. It's got to be 2 less than whatever that is, which is 41. All right, so Lewis drew a picture to make sense of problem 5. Explain how he can use it to find N. I'm going to pause the recording so we can switch classes, and then we will start back up. So we're back here on problem 6. So Lewis drew this picture to make sense of problem 5. Explain how he can use it to find N. So here's problem 5. They first looked at it using a mobile. Okay, and he drew it a little bit differently. It's not in just a table form. He's actually using the length of each segment here. So he knows that if I add the length of 43 plus the length of 28, I want that to equal the length of N plus the length of 30. So we can easily look here that 28 is 2 less than 30, or 30 is 2 more than 28. So this difference right here needs to be a 2. Okay, so N has to be 2 less than 43. So we can just write a sentence here explaining how. So using the length of each segment. We see that N needs to be 2 less than 43. Okay, so one way to explain it, your writing may be just a little bit different than how I wrote it, and that's okay. Okay, so here we drew a picture to make sense of problem 5 again. Explain how she can find N. Okay, so 28, 43. So this equals this. Okay, so adding these together and then adding these together. All right, so right here we can see that 30 is 2 more than 28. So on this side, N needs to be 2 less than 43. So this one kind of goes back up to this diagram. As we went less this way by 1, this way increased by 1. So we can use this number line here, and as I go further this way, if they have to equal, I got to go further to the right there. Okay. All right, number 8 says, the green line here shows another number line relationship. It connects numbers whose difference is 4. Here, the green line connects 1 and 5 because 5 minus 1 is 4. And you can see there's 1, 2, 3, 4 spaces in there. Draw 3 more lines that connect numbers that differ by 4. Okay. Well, let's go with 10. Okay. 10 minus 6 is 4. 1, 2, 3, 4. If we use some negative numbers, 1 minus negative 3. 1, 2, 3, 4. And we'll write the equation here. I got 10 minus 6 is 4. 1 minus negative 3 is 4. If I get one more, let's say 7 minus 3. 1, 2, 3, 4 spaces. So 7 minus 3 is 4. So a line segment can help us do some subtracting, and the subtracting is just the distance between those two numbers. Here's a line between numbers who differ by 50. Draw 3 more lines that connect numbers that differ by 50. So 50 minus 0, so went to 50 to 0, which is 1, 2, 3, 4, 5 spaces, is 50. If I do 10 minus 40, 10 minus 4, sorry, 10 minus negative 40 is 50. If I do 20 minus negative 20 minus negative 70, and again, you can count 1, 2, 3, 4, 5 spaces. So negative 20 minus negative 70 is 50. Okay, so we got some negative numbers here that will help us out. Negative 40 minus negative 90. So negative 40 minus negative 90 is 50. 1, 2, 3, 4, 5. Again, you can count the spaces there. Figure out the value of the variable using the number line, not by subtracting. Okay, so we're looking for an alternate way to solve these algebraic expressions or equations, okay, instead of just adding and subtracting. Number lines are models so that spacing doesn't have to be perfect, but the order always has to be correct. So it doesn't matter how far between here and here, as long as the order of your numbers is correct. So we have 52 minus 19, and then some number minus 20. They have to equal. Well, here we have a difference of 1. Okay, difference of 1. So here we must also have a difference of 1 for these arches to be the same distance away. So in that case, this has to be 53. Okay, so the next one here, we've got B. So you've got 83 minus 37 and 80 minus B. So right here we have a difference of 3. So here we need to have a difference of 3, and it has to be 3 less. So 3 less than 37 would be 34. Okay, so we're just really looking at the distances between these things. Okay, let's read this here. Using tools strategically. Using the number line is not a new way to add and subtract. It's a way to sort out your reasoning about addition and subtraction. Focus on the order of the numbers and the distances between them. Okay, so we got 487 and minus 290. So here we're going to have 300 here. So this is 10 more. So then C needs to be here, and it will be 10 more. So that'd be what, 497? So So 497. Okay, all by using that distance. Okay, so when the numbers get really far apart, again, it doesn't matter that we're spaced out evenly, as long as the order of our numbers and the pairing of our numbers is correct. So I'm going to put 8,000 here, and then I'll put 7,998 here, and over here I'll put 179. So I'm taking this number minus this number, okay, and then 8,000 minus some other number. Now, this has a difference of 2, so this should also have a difference of 2, and in fact, it will be more, okay, since the 8,000 was more, this one's going to have to be more. So mapping here to here, notice they cross on all of these things. Okay, on the subtraction, they all cross. Okay, and this was D, so it had to be two more. So we're at 181 for that one. Okay, so this purple section, discuss and write what you think. If you are told that 77 plus m equals 80 plus 43, explain how you can find m without adding 80 and 43. All right, well, one way you could explain it is that 77 is 3 less than your 80. So in order for these to match up, you're going to have that difference reflect in the 43 and the m. So if 80 is 3 more than this number, then this number must be 3 more than this number. Okay, so 77 to 80 differs by 3. So 43 to m must also differ by 3. Okay, and the 80 is heavier, so then m has to be heavier. Okay, it's got to jump sides. So 43 plus your 3, so m equals 46. Okay, for those to be balanced. If we know that 97 minus 75 equals 92 minus x, explain how to find without ever figuring out what 94 minus 75 is. Okay, well, 94 to 92 differs by 2. So x to 75 must differ by 2. Okay, and since 94 is the heavier one, the x has to be the heavier one. So that would be so 94 to 92 differs by 2. So this is the heavier one here. So x to 75 must also differ by 2. And we can also kind of up here, we use the number lines here. So I got 94, 92, 75. So it took 94 to 75, 92. So that one's got to be less by 2. So 70. So x equals your 73. Okay, so we can use kind of that diagram to help us out. Okay, because this subtraction measures a distance, so the distance has to be the same. Okay, so that is all for the first part. You've got some page 10 and 11 to give it a try. You can also be working through page 12 for your quiz. Thanks for watching, and we'll see you in the next lesson.